Ashley.
Okay, quick Facebook Live. That's actualizing. Got it. Okay, I'm gonna let everybody in.
Steve joined us. Okay.
Good morning, everybody. Thank you so much for taking time out of your week to join us for this very exclusive webinar hosted by Centurion Technologies and Scheider Electric. This is a huge opportunity for you all and for us. We are so excited to bring this to our partners. My name's Ashley. I'm in marketing at Centurion Technologies. I'd like to really quickly introduce Craig Kuchbaugh. He is the owner of Centurion Technologies, and thanks to him and his partnerships, we have this opportunity today. So good morning, Craig. Thanks for this.
Good morning, Ashley, and thank you for putting this on for us. Today, we all have a unique opportunity to learn about some new products that's going to well prepare us for the future as we move towards a greener environment. We are fortunate today to have Don Wingate and Samantha Childress host us. They are both with the Microgrid Competency Center with Scheider Electric and are very knowledgeable about the industry. And I'd like to thank all of you for taking time out of your day as well to learn about our new projects. This is an exciting announcement for Centurion Technologies as well. There will be many updates on our webpage. So please join us there at times to keep up with what we're doing at centuriontechnologies.com. And I will turn it over to Don Wingate now to start the webinar. Thank you.
All right, hey, thanks very much, Craig, for introducing us, and also thanks for letting us participate in your webinar series. I want to maybe just start out by reminding anybody that might have been on one that we held back in April, where we talked about the microgrid industry. We talked about the need for new systems and technologies, and really a way to learn from the past and apply it to what is needed today in the industry. So we're going to talk about something called Microgrid Flex. It's a new product offer that we have. And I'll run the slides here. See if they will actually advance. There we go. So what I want to talk about today is what is really the market for microgrids? What have we learned? We want to talk a lot about this new offer that we call Microgrid Flex, that is really, I'll call it sort of a microgrid in a box concept, and how we put things together that are going to make it easier and simpler for people to deploy microgrid solutions. We're going to really define the concept of configure to order for a microgrid, but more importantly, why does it matter? And why is this important to the industry, for end users, and for our partners? And spend a little bit of time on the benefits of it. So that's where we're going to focus some energies today. But I do want to level set a little bit and remind everybody what a microgrid is. And it's really a collection of interconnected resources that generate energy and tied to the loads, whether that be the needs of a building, the needs of a manufacturing facility, the needs of an electric vehicle. How do these loads and generation and demand work together? And how do we do that in conjunction with leveraging what's existing, which is the utility interconnection? But at the end of the day, these microgrids all really have three things in common from a benefits perspective. It's how do you optimize the cost, and a better way to say, how do you reduce cost and make sure that it's predictable? How do we add another level of resilience to facilities and make sure that things actually work and provide the power when you need it and at the power quality levels that you need to operate your facilities? And how do you do things in a much more sustainable manner? And those things are not always equal in everybody's mind, but every time we talk to people about microgrids as a business, those three are the ones that are come to the top of the list. I do want to also remind everybody that there's really three different styles of microgrid. And as it says on the chart here, there's this always-on grid-tied microgrid that's not islandable, and I'll explain that in a second. There's the islandable microgrid that says if the power goes out, the microgrid will pick up the slack and really keep you operational during blackout periods and brownout periods. And then the third one is off-grid facilities. And for our microgrid flex offer, we're really going to focus on the first two. And the reason we're differentiating these two different types of microgrids is the fact that we want to offer more choices to people. For example, if in an islanded mode, there are many parts of the country and states where you have pretty poor power quality. There's a lot of storms or wildfires, weather events, and things are not as predictable and available. So we have microgrid capability that provides that. But it's more complicated. We have to make sure things are safely done and that we're transitioning to the grid on and off in a sensible manner. But there are other parts of the country where there's really good power quality, right? And you may have a particular business that resiliency is not that critical to you. For example, you might be in a school system, right? And while it might be irritating if there's a 2-minute outage, it's not that critical to the facilities. So why do you have to pay for a more complex system when you need one that's less complex? And you might want to focus just on cost optimization and sustainable services. In an islandable mode, a 2-minute outage might be meaningful to you. I happen to attend an auto manufacturer facility a year or so ago, and they had a 2-minute outage. And what it did is it cost them an entire shift of production. They had to send people home. They had to redo all their automation equipment. Very, very expensive. So we just want to make sure that there's two different ways to look at things, and we want to make sure we can provide the right solution at the right time with the right set of functionality. But when at the end of the day here, what we want to do is take the lessons learned that we have over these very complex microgrids that we've put in place over the last 10 years. We want to leverage proven products, and we want to come on a way to say, what are some of the things that we can do in a more configured to order, simplistic fashion, like optimize the cost, provide the sustainability and help people meet their sustainability objectives, and provide the right level of resilience with the advanced controls that we have to make things work. And the other thing that we're doing with Microgrid Flex is we're really going to rely on our partner network. Like Centurion Technologies is going to be able to do this. And we need partners to go to market. And we're going to be able to provide them tools and help and design assistance to help make sure that things can get done in a much faster environment. The other element that we have here is that we want to be able to offer as an optional capability to people an energy as a service model. And this is where we would work with either ourselves or our partners to be able to build, install, operate, maintain, and ensure energy outcomes from day one without asking people for an upfront investment. And this is having people buy the production of a microgrid over an extended period of time. So Microgrid Flex is a way to have a simpler, straightforward, easier to implement system geared to people's needs. Do it that drives energy costs, sustainability, and resilience, and do it in a way that we think is going to be help the energy transition and take the microgrid industry to through an inflection point of one-off systems to ones that are more configured to order, to go to a volume distribution model. So I'm going to turn it over to Sam, who's going to talk about Microgrid Flex and what it means to you. So Sam, take it away, and I'll run the slides.
Perfect. All right. Thanks, Don. Thanks, Craig and Ashley, for allowing us to present to you all today. First of all, I've been at Schneider for about 6 years. I've been leading our some of our microgrid solutions, and I'm really excited to be joining Don and the team here to launch this new offer, to bring it to partners, and to help grow and scale the market in a way that, you know, makes microgrids more approachable for folks who haven't invested in them in the past. So I think, you know, for me at least, I'm a pretty visual person, and so I love this kind of image of, you know, what is Microgrid Flex? What is a microgrid? What could it actually look like at a site? So we'll take a second here to just paint the picture, and then we'll go dive into some of the more technical details as we go through the slides, and what it can mean from an outcome perspective for customers. So we'll start at the top left corner. As you see, we have a couple of battery containers. This is a key part of our Microgrid Flex product suite. So our battery energy storage system being launched later this year can start at 60 kilowatts worth of power up to 500 kilowatts and a megawatt worth of power there. So providing a fully packaged inverter, packaged battery cells in a nice tested and configured manner is a really important way to de-risk microgrids. As we see tariffs changing, as we see more new loads and electrification, things like electrical vehicles coming online, battery storage is a key part of maintaining a stable grid, and also allowing you to get more of your on-site energy resources. So key part of our Microgrid Flex offer suite is that battery storage component. You see it tied into that solar PV in the top right corner. And both of those resources, as well as your conventional backup diesel generator, if needed, can tie into a building in a more seamless way, in a smoother, easier to commission manner that is more productized. As Don said, you know, if we're deploying this at scale, we want to help the market make it easier, simpler to configure, deploy, commission these resources. So where we bring those resources together is the piece of the Microgrid Flex called the Energy Control Center. That Energy Control Center on the right side of that electrical switchgear room is a 3-section switchgear lineup. We have circuit breakers that are smart, embedded with you know, meters, data collection points, things like that are bringing visibility to your energy resources. They're also serving as the control point for that microgrid system as well. The brains behind the microgrid are actually going to be living in that middle section of that lineup there. It is the control section of the Energy Control Center. It is where you're doing all the data collection, you're doing the data crunching, the analysis, and you're communicating with the cloud to get the most of your energy resources there. So we're packaging this Microgrid Flex in a way that becomes factory tested. It comes to the site pre-configured, and from an installation commissioning perspective, we're aiming to help folks get microgrids up and running faster. And the key point there is that these are long-term investments that folks are making in microgrid systems. You're helping meet your sustainability goals for the long haul. You're helping to decarbonize your site. You're helping to optimize your finances. And so deployment of these, getting these sites commercially available, up and running, becomes a key part of deploying microgrids at scale. And so our aim is to help you get it online faster, get it producing energy faster, making money, making sure your site's resilient as quickly as possible there. So that's kind of some of the main reasons we've created this Microgrid Flex offering. And I'll just quickly touch on a couple of the tools we've created over on the right side of the screen. So one of the key parts of designing any microgrid solution is making sure it's achieving those financial and resiliency outcomes. And in order to do that, you want to design it with the actual technology and the sequence of operation and the use cases that you're going to be using it for the next 5, 10, 15 years or longer. And so our design platform helps you to make sure that you're getting the most of your energy resources, that you're optimizing it for the actual site use based on the energy load, based on the tariff structure that the customer has. And so that design platform is helping to do those pieces, making sure you're investing in the right size assets and things like that. The second piece of our toolkit to help folks bring to market Microgrid Flex is a platform we call EcoStruxure Microgrid Build. And that Microgrid Build platform is really there to help configure the use cases and then upload those configurations to your microgrid control cabinet. So you're actually going through, you're saying, hey, I know what my site needs to do these 3 things. I know it has to have resilience, and I've already done the design piece. And so I'm ready to get my my program, my code for that microgrid and upload it. So that microgrid build is helping you run through the sequences, upload it to the actual hardware components inside of that microgrid control cabinet, and help us factory test it and then ship it to site with all of those things preloaded. So minimal work on site to actually tie in the DERs, the energy resources there, and bring it to life through some of our digital tool configuration. And then the last piece on this screen here in the bottom right corner is our EcoStruxure Microgrid Advisor platform. This platform is used to operate and maintain your system throughout the life. So you're investing in this, you have these use cases that you're trying to meet, and we'll go into some of those use cases in a little bit here. But how do you see it? How do you know it's working? How do you visualize that data and understand how those outcomes are being achieved? And Microgrid Advisor is a platform to give you that visualization. So it's helping you real time look at your site consumption, your site generation, and balance those things for you, the site operator, the end user, things like that, to have a picture of it. So that's kind of the Microgrid Flex visualization in a nutshell. And I'll have Dawn flip it to the next slide here, and we'll go through a little bit more of what that means. So the Flex platform is really trying to achieve something that we've done in projects businesses, but bring it to a new type of market in a simple, standardized, and validated way. Our goal is to make microgrids scalable, to make you all and our partners be able to invest and grow the microgrid market much more quickly, much more simply than we have been doing so in the past. So it's just another picture here of what those components really look like. Inside of that energy control center piece, you have your control stacks, you have your controls components, you have your switchgear, the brawn of any microgrid with the circuit breakers, the metering, things like that, all tied to your site. So in order to help us achieve our decarbonization goals, in order for us to help achieve our resilience goals, this Microgrid Flex platform is really bringing together the tools and components to bring that to life. You go to the next slide, Dawn. I'll kind of go through the stack, as we like to call it sometimes. So if you're investing in a microgrid, I'll start at the bottom and work our way up to the top. So if you're investing in a microgrid, the things you're probably most familiar with are battery storage and solar PV. These are the actual distributed energy resources. And more, we're seeing new types of distributed energy resources, which include EV chargers. It might include your building automation system, which is a controllable load. It might include future energy resources on the horizon, like fuel cells and long duration storage and things like that. All of those are distributed energy resources. They're the individual components that provide flexibility to a site. And so in order to achieve an optimal performance of all of those DERs, you need to tie them in to a centralized point which we call our energy control center. So bringing together the loads and the sources in one package in that energy control center, and then making the most of those resources is really the differentiation that we're bringing in that control piece of the microgrid. So our control stacks, one of those control components sits at the edge. It's called our EcoStruxure Microgrid operation. That microgrid operation piece is really there to determine, is the utility powered good? Is it, are we experiencing an outage? Are we experiencing some inconsistency in frequency or voltage? And should we stick with the grid power, or should we self-isolate, and should we operate as our own entity? That edge device is making those real-time decisions on whether we should stay connected or we should isolate from the grid. So kind of that edge piece there. And most of the time, your microgrid is connected to the utility source. 99% of the time, right? Our power is good, no issues. And what we want to do with that microgrid is make the most of those energy resources. You want to look at things like your weather forecast to know how much solar you can actually produce at your site. You want to look at things like your historical energy use data. How much did my site consume on a Tuesday afternoon at 5 p.m. in the past? And how can I use that knowledge to predict what my site is going to be doing for the next 24 to 48 hours in the future? And then how do I come up with a schedule to enable my energy resources to make the most of those assets? So optimizing the historical future-looking data to come up with a schedule, crunch the numbers using AI and machine learning algorithms to predict, optimize, and operate that microgrid over the long haul. So those are kind of the high-level stacks here. I definitely want to touch on that far right column that is services. So with any type of microgrid system, you want to make sure, like we said, that you have the right sizes of resources. We're developing some tools for the market, but if that's not something you want to take on as a customer, as an end user, or as a partner, we offer services to help support that design work. We also do design work that helps you make sure you can manage your interconnection aspects with the utility and get in the interconnect queue and get all the applications in appropriately. So those are some of the services we can provide on the upfront design stage. But critically important is the long-term servicing of a microgrid. So if you're investing in a microgrid, you have a customer who has critical resilience needs. You want to make sure that that system is ready to go, and site load conditions change over the course of years, and new loads can be added to the site. And as you're investing in this microgrid system, you want to make sure that system is well maintained throughout the life. So we also offer long-term service agreements as a core part of this microgrid offer, because these are long-term investments. We want to make sure they are functioning for you, the end user, over the course of the long haul there. So long-term service piece is an important component of the Flex suite. I think I saw a question in the chat. Should we go to those now, or should we tie into those at the end? Craig, Don, I didn't get a chance to read it yet.
I'll go ahead and read it. Let's answer it if we can. Meg asked, would this work in place of generators like for hotels?
Yes, absolutely. Great question. Thanks, Meg, for putting that in the chat. And we can talk a little bit more about some examples at the end if we have time. But the short answer is certainly this can work in lieu of or in complement to that standard backup generation kind of methodology. So you can tie in a diesel generator, for instance, that's already there into the energy control center, and it can be optimized as a part of the system alongside the solar and battery storage system. So it's kind of bringing all of those resources there together, or it could be used in lieu of that diesel generator if you just wanted to use a different kind of resources there as well. So great question. Okay, I'm going to tie in here and just talk a little bit about CTO and ETO. And at Scheider Electric, we like to use a bunch of acronyms here. So I want to start first by explaining what these acronyms mean, and then talking a little bit about how Flex is addressing those components. So CTO is what we use to define configured to order. This is exactly what Microgrid Flex is. It's configured to order. That is in comparison to engineered to order, ETO. Engineered to order is great. It's also a really important thing for complex buildings, complex campuses that all might look a little bit different. And so engineered to order is a way to build microgrids that meet a very niche specific sort of goals and outcomes for a customer. And we continue to do engineered to order microgrid projects. They're customized. They are going to be different types of electrical architectures and different types of distributed energy resources. So if you're looking at, you know, I'm really interested, or my customer's really interested in hydrogen fuel cells, for instance. These are newer technologies to market. These are engineered to order systems, and they're going to achieve outcomes in a different way than what our Microgrid Flex can do today. Now, ultimately, we expect that, you know, fuel cells and long duration storage and things like that can become part of a configured to order system, but we want to be crystal clear that that's not where we're starting with configured to order. Those are things that will evolve on the roadmap over time. So our projects business is going to continue to do those large customized niche microgrid projects. And what we're launching here today with partners like Centurion is our configured to order solutions. And that means we have standard service contracts, we have standard tools and use cases for those microgrids. And then we also have standard architectures for bringing in, how do you tie in your distributed resources to a typical building profile. And so that's where we fit in our energy control center in a configured to order manner. So we have a standard set of distributed resources that we've used. And the key part is we're actually testing all of these distributed energy resources in our Andover microgrid lab in Massachusetts. And so if we're going with this configured to order approach, the key is we have to test it, we have to pre-configure it, we have to make sure that the tools and the use cases are ready to deploy those resources in a quick, scalable manner on site. So that's kind of the approach with Microgrid Flex. Whereas on the project side, we can do as much testing as possible, but there's still going to be some use cases there that might not be achieved in a testing environment.
Hey,
So,
Sam.
yes.
Meg kind of continued her question. It sounds like it might be timely right now. What is the typical turnaround time for custom builds?
Good question. So custom builds can be anywhere from a year's worth of design, you know, customer acquisition, getting folks comfortable with making an investment, just on the kind of commercial side, getting us to a point of having a full design. And then it might be another year to 2 years to you know, manufacture, build those systems, and then commission and have it actually up and running. So it could be anywhere from like a 1.5 to 3 year kind of ordeal for microgrid projects, in some cases longer, depending on if they're phased and how they're phased. But certainly a longer lead time kind of endeavor there on the project side. Where we see Microgrid Flex providing a lot of value is essentially the standard use cases are already pre-configured. The design is going to be shortened to an order of months to find the customer, get them on board, to do the design, and be able to order the components. Where we're also achieving a shorter lead time, a shorter time to market is actually in the manufacturing process. So by standardizing the electrical distribution, by standardizing the parts that we're using, we're able to build these configured to order systems in a matter of months instead of a year. So a lead time today for a smart switchboard and energy control center in the ETO world could be on the order magnitude of 50 to 60 to 75 weeks, depending on complexity. And what we're able to achieve with the configured to order energy control center in the Microgrid Flex world is more like 30 to 40 weeks lead time there. So getting your parts and components in less than a year can be a huge advantage to customers wanting to get that up and running. I hope that answered your question, Meg. Appreciate you, providing good talking points here as we go through. So keep those coming. Okay, we'll move into our next slide here. Just want to give a couple of more specifics of where we are starting at with Microgrid Flex. These guardrails are really important to achieving that 30 to 40 week lead time, to getting components ordered and delivered in less than a year. Some of these details might be a little bit too in the weeds, and some of them might be just right for you. So we'll just run through them very quickly. We have embedded in that far left cabinet all of our electrical smart components for that microgrid system. So we have our microgrid controllers, we have our metering points, we have our relaying, all standard engineered configured components as opposed to engineered components in that cabinet. In the right column, you see a stack of breakers. This is the piece that is configurable to your site. So there are 3,000 amps of section in there that you can stack your load breakers, your generation breakers, and that means you can have up to 500 kilowatts or so of a battery. You can have up to a megawatt or so of solar photovoltaics, another 500 kilowatts of a generator if needed for your site, and then the rest of that space can be used for your smart sheddable loads, and that could be anything from you really want to keep on, this subset of office rooms in a building. This might be something where, if an outage happens, you can actually shed this half of your manufacturing plant or this half of your office building, things like that. So all of those are kind of configurable. The HMI screen is also configurable. Not everybody wants the HMI screen. If you do want it, it is an option. And the other option you can have in this Microgrid Flex guardrail is whether you have it indoors or outdoors. So this comes in both a NEMA 1 and a NEMA 3R configuration for folks, depending on space, depending on whether it's a new construction or a retrofit as well. So those are kind of the three pieces that are configurable. And beyond that, we are launching this with one battery energy storage system that is pre-tested, pre-configured, and a couple of different PV inverter manufacturers. So the first ones we are testing and mapping to our Modbus registry are SMA and SolarEdge. So those are kind of the two manufacturers there that we'll have pre-configured in our distributed resource library. So a couple of high-level guardrails there for us to focus on here in order to achieve that fast lead time, fast commissioning, and seamless scalability for the microgrid market. Let's see, I think we can move to the next slide here, Dawn. I haven't seen any other questions, I don't think, crop up. All right. What are the use cases? What do you get? What are the outcomes of these microgrid technologies, and how are we able to achieve it? Well, if you're investing in a solar PV system or battery storage system, the basic thing you're going to want is remote monitoring. You want to know what that battery is doing. You want to know what that solar PV is producing, and you want to be able to use that to forecast what's going to happen at your site. So that's kind of that top grid tied use case. Every site is going to want that. It's going to need that as a standard part of the use cases. Depending on where you are, where the end customer is, and what their tariff structure is, you're going to certainly want tariff management, tariff optimization. So, in the morning, your cost of electricity might be different than what your cost of electricity is in the evening. And you want to be able to optimize when you're storing power versus when you're dispatching power to your site from your battery, and when you're wanting to export power as well. So all of those are kind of your standard use cases for any given site, and might be selected based on the tariff structure that a customer is on. The piece that is, not always necessary, but in some tariff structures is necessary, is this demand charge reduction piece. So for instance, some small buildings, actually, there's no demand charges, right? So you don't necessarily need demand charge reduction. In other cases where customers are actually penalized for new peak demands, you want to be able to use your battery, save it up, and then dispatch it for those high demand charge times of use for the building. So those are kind of options to select whether you have that tariff structure or not. And then increasingly, we're seeing a need and a desire from the utility perspective to minimize export. And so if your utility interconnect agreement says, hey, no export of your battery storage or your generator or whatever it is, one of our standard grid tied use cases is to help real-time export management. So you don't have to export, or you can export your minimum requirement there from the utility. So those things are sort of configurable. The piece for that islanded type of system that's being managed is your grid connection management. So whether you need to be islanded or whether you are going to be on your utility, that grid connection management is optional. And then load shedding as well. So certain customers might say, hey, I want everything in my building to be backed up. That can be achievable, certainly. And you might have to upsize your distributed energy resources to achieve that full load, full building backup. Some customers say, hey, I actually don't need to run 100% of my building or 100% of my operation when there's a power outage. It's going to help me save, on my battery storage. It's going to help me save on my diesel fuel that I'm going to use. And so I'm actually only going to use 30% of my building when an outage occurs. And so that load shedding piece can also be configured based on the site's needs. So those are kind of the high level use cases we have. And in order to achieve that time efficiency and reliability, these are kind of the specifications that we've provided, tested with our distributed resources in our lab, and can bring to market in a validated and simpler way. This is kind of walking through what happens when there's actually an outage. These are the standard outage sequences that we go through that our energy control center and our microgrid controller, the whole Flex program kind of enables. So during grid connected mode, we have our economic optimization. When the utility outage occurs, our microgrid controller or microgrid brain behind it opens the main breaker. It starts our grid forming assets. In this case, it would often be a diesel generator that comes on first. We bring on other resources as well, such as the battery, the solar PV, and we're able to use all of those energy resources to stabilize the microgrid. And then we're also operating in a way that's minimizing the amount of fossil-based resource that you have at the site. It's optimizing the amount of on-site clean fuels that you have, the solar PV, the battery storage, and then it's serving all of the loads of the building there for the duration of that outage. When the grid becomes available again, we have what we call an open transition, which means there is a momentary outage to go back to the grid. This is a pretty short duration outage. It's often not very noticeable from a facilities perspective. So you turn off your generator, you turn off your solar battery, and you connect back into your utility system, and you stop the grid forming assets there. So then you're back in grid connected mode, again, optimizing your site based on those financial and economic characteristics that you're trying to achieve. So just walking through a quick example of a power outage scenario here. Let's see what we got next here. All right, what is the typical target for a customer in the Microgrid Flex product suite? Based on the size of the energy control center, based on the size of our battery storage systems in the market today, we are targeting C&I segments. small, medium buildings that can achieve up to 1 megawatt worth of solar photovoltaic installation. That's 1 megawatt AC. A battery can accomplish a battery storage of about 500 kilowatts. May not have to go that high, but that's kind of where this sized ECC tops out. And then our generator at 500 kilowatts as well, to be used in lieu of the utility when a power outage occurs. So power outage happens, generator turns on and acts kind of in lieu of your typical utility source there. The loads can be configurable, like we mentioned earlier, up to the available space and bus ampacity that is remaining. So these are kind of the target market here. We are starting with Microgrid Flex and this size, and we expect to release other variations of the Microgrid Flex product suites in the future, but we can't boil the ocean, so to speak. So we're launching, hoping to achieve the target C&I segments first, and then growing our product portfolio here thereafter. Let's see, I think I saw one more question in the chat. Let's see.
Look at that.
The breaker operation for priority loads is similar to a dedicated ATS for life safety. Does this operable breaker comply with a dedicated emergency power EPSS? What does the two S's stand for there, Kelly? If you could drop that in the chat for us, just so I can make sure from a semantics point that I'm addressing that. Supply system, emergency power supply system. Thank you.
I would like to give you kudos for getting that acronym almost correct.
Only halfway. I've seen it before, but I just wanted to make sure. In some building codes, you are required to have an ATS. And I'll flip to another slide here at the end, Kelly, and we could talk through that a little bit. But essentially, there might be a need to have an ATS in addition to the Energy Control Center. So there's a couple of different building architectures that can achieve that emergency power supply system code requirements. In other cases, you might not have to have that ATS, or the breaker could supplement or stand in for that ATS as well. So I can show a couple of slides there at the end to talk a little bit about that. Just kind of in summary, before we get to some Q&A, I want to highlight, those key outcomes that we're offering to both partners and end users with this new launch of the Microgrid Flex offer. One is the lead time. Like we said, how do we bring this to market fast? How do we do it in a way that's simple and that makes microgrids approachable and monetizable sooner, getting the most of those investments. Second piece is that reliability piece. So how are we making sure that buildings that really need to be operating despite, power outages, despite, emergency events, they have that reliability piece and can do so in a way that is making the most of the clean and available fuels on site that you've invested in. Third piece is that cost efficiency. So taking a lot of the engineering, the custom engineering out of the upfront design phase of a project and bringing a cheaper, more efficient solution to the market faster, reducing the life cycle costs as well through standardization of the components, standardization of the battery, regular performance and maintenance plans there to complement the full suite. And then simplicity. We want to make the interconnect process as seamless and easy as possible. We know there's a real challenge in the distributed energy world in connecting microgrids to utilities. And so our goal is to standardize the hardware and software and make those approvals easier for the market. We want to also make it plug and play for where you can move to your next project faster, for how you can get that site up and running, and then also have a standard way to maintain these systems throughout the life cycle as well. We want to help you accelerate your markets. We want to help grow the larger microgrid market. We want to make microgrids more accessible, more approachable for the entire energy value chain. And with that, I think that might be our last slide, and we can jump into some further Q&A. Is that right, Don, or did I miss?
Yeah, it is. I do want to maybe just add one point, and Sam did thanks. You did a wonderful job of explaining a lot of the mechanics and technology associated with the Microgrid Flex product. But the concept of having guardrails is really, really important to us, because we're with Flex. It's got to be tested. It's got to be validated. It's got to be documented. And that's the way we're able to cut the delivery times, reduce the costs, make things more repeatable in the marketplace. So we're starting with certain things. As an example, we're starting with a 3,000 amp system. It's not a 4,000 amp system, right? So what we're saying is that let's figure out how this could work for people. And rather than saying, what do you want, we'll build it for you, this is what we have, let's figure out how to make it work. And then if it doesn't fit, then of course we'll go to the engineer to order model. But we're finding that the initial feedback we're getting from the market with some of our pre-orders was that this really fits the bill for a majority of applications. When we look at history over the last 3 to 5 years, the average size of a microgrid was about a 9 megawatt microgrid. The projected space for microgrid is this 1 megawatt microgrid. That's where the next growth is going to come from. And that's why we came out with Microgrid Flex, starting with this 1 megawatt type system. So anyhow, we're running near the end of it. We left some time for questions and answers. So people could throw them in the chat if you have anything, and we're here to talk about this.
In the meantime, maybe Don, you could flip to a couple of the appendix slides. Can't remember what slide exactly it's on, where we show the ATS in the architecture.
I may have to use a different deck because I got rid of the appendix.
No worries. We can also talk about it a little bit offline too, or when we share out the deck as well. Maybe we can include that one in that.
Yes, I'm happy to include that deck, or at least the appendix in the email that will summarize everything that we've gone over today. We'll also include the video recording, and then everything will be available on centuriontechnologies.com under the news section. So that's a really great place to kind of circle back to here in these weeks following this exciting product launch.
Awesome. That'll be perfect.
I'm not seeing any questions come in or any hands raised or anything like that. So I'm happy to kind of put everything together with the two of you and summarize things and not keep anybody. Oh, look at that. Meg just populated the chat. And so if you're okay, we'll go ahead and answer that. Could these be a portable system for MHP? There you go, Sam, another acronym.
MHP, I am not familiar with. Matt, could you help us out there? Maybe I should be familiar with, but I'll memorize it after you share it.
I guess it's I'm not going to guess. So
says in her chat, she says mobile home parks.
Oh,
Thank
thanks.
you.
This hasn't populated for me. Mobile home parks.
Which here in Arizona we have a great deal of.
Okay. No, that's good to know. So kind of more community-based microgrid systems that serve a larger population. Certainly applications may lead itself to community-based systems. However, where we're starting is if you wanted to make this a portable type of system, we could offer the microgrid Flex, the energy control center, the battery storage system, and others could skid it up, put it on standard pads and things like that. So I don't want to say no, but it might be a different type of configuration that we could work through for certain applications. we're typically looking at serving a single end user site based on this today. So that's just for feeding homes that are ranch fed power as a backup. Homes. These systems are often going to be larger than residential type of applications. So that's the one kind of caveat there. It'll probably serve, loads as low as, call it 100 kilowatts up to 1 megawatt worth of loads. But oftentimes homes, even some of the larger homes, are often more in the anywhere from 10 kilowatts to 50 kilowatts range. So it might not be the perfect application for that from where we're launching today. Not to say
There
that
are,
can't-
however, products in the pipeline on another section for Resi to
Absolutely.
manage those things. So they
100%.
certainly will be available.
Yep.
I think as we run this to the close here, I want to remind everybody that this is why this product is really matched well with our partner network, right? Where, there's several things that, we're the technology provider, Scheider Electric, a $34 billion corporation that's global. But we need help, right? We need folks like Centurion that's going to be able to help figure out what the design is going to look like, do some of the civil mechanical, provide the electrical, the electricians to put this in place, to help with the commissioning, figuring out what the right product sets are, and providing the photovoltaics, providing the rotating equipment. Schneider Electric is going to have the controls, we're going to have the capabilities, we're going to have the design assist to help people put things together. And we're going to really rely on our local partners to help figure out the right set of things that we can bring to the table. So if that makes sense.
Let's see, do we have any other final questions here? And if not, we can always take questions offline via email, whatever. Cool.
So I'd like to personally thank everyone for taking their time to learn about our new product offerings at Centurion and learn more about our partners that we are working with. Thank you for joining us. Ashley, thank you for hosting us. Don, Samantha, greatly appreciated all your help and support.
Appreciate you giving us the platform to share and look forward to growing this market together, Craig.
All right. Okay,
Thanks,
well,
everyone.
have a great afternoon, everybody, and I am very thankful for the opportunity to share some of this information.
Thanks all.